Okay, we are going to talk about algebraic relationships. First, we're going to talk about algebraic properties. We have the identity property. So an example would be adding any number to 0. So if I simplified 7 plus 0, that would be 7. Another example of an identity property would be 7 times 1 equals 7. All right, then we have the commutative property. So that is where in multiplication or addition, you can change the order of the numbers and it is not going to change the value. So 4 times 2 times 5 is 40, and 5 times 2 times 4 equals 40 as well. So that's not changing the value of the expression. You can do this with addition as well. So for example, 5 plus 4 equals 9, just like 4 plus 5 equals 9. The associative property is when you move where the parentheses are, where the grouping is. This works for addition and multiplication. So the value of this expression is 14, and the value of this expression is also 14. You can do this with multiplication. So 3 times 2 times 1. This is 6. If I do 3 times 2 times 1, that is also 6. Distributive property is where you have this number on the outside called a coefficient, and you multiply it by the numbers inside the parentheses. So 9 times x is 9x, and then 9 times -4 is -36. So that simplifies to 9x minus 36. All right, prime factorization is where we are going to break down a number into the factors that are prime of that number. So I'm going to think to myself, what times what is 78? I know that 78 is a prime, or sorry, an even number, so I know it can be divided by 2. A prime number is a number that can only be divided by itself in 1, so I can't break this down anymore. That's a prime number. 2 times 39 is 78. Can I break this down anymore? 3 times 13 is 39. I can't break 3 down anymore with a whole number. So my prime factorization is 2 times 3 times 13. All right, what is the difference between an expression and an equation? So here where it says expression, it says the sum of a number, so an unknown number, and 13. There is no equal sign. It doesn't equal anything. And another example of an expression is here what it would look like in a model. So I have x, and let's just say I have this. This would be x plus 4. This is an expression. An equation has an equal sign, so sum of a number and 13 is, that keyword is, means that equal sign 26. A model of an equation could look something like this. So that would be 2x equals 4. So an equation can be solved and an expression can just be simplified. All right, talking about order of operations, we use this tool to help us figure out how to simplify the expressions to its smallest form. Parentheses, we solve the parentheses first, then the exponent, multiplication or division, whichever one comes first from left to right, and then same concept for addition and subtraction, whichever one comes first left to right. So we are going to solve we have parentheses. Inside the parentheses, we do have an exponent, so I'm going to rewrite this. 9 minus 5 divided by 2. Then I'm going to solve inside the parentheses. Then I'm going to do 4 times 4 next. Then 16 divided by 2. And then 6 plus 8 is 14. All right, this time we have a distributive property happening here and we have a variable. So we cannot simplify in here at all, but we are going to first do the exponent. Actually, we're going to work with the parentheses. We're going to distribute this. So this is 12x minus 8. Then we'll do the exponent. And we're going to combine like terms, so we cannot combine this with anything because we don't have any more x's. So we are going to do 8 plus 12 next. I'm actually going to treat this as negative 8 plus 12. So that's positive 4. And then 4 minus 4 is 12x. All right, we're going to talk about additive and multiplicative relationships. So in an additive relationship, the graph will not, and the points in the table will not go through 0, 0, the origin. So this is my point values for x and y. The way I figured this out was I used the equation y equals x plus a. So that in this case, it is y equals 0 plus, so in that case, y is 1, x is 0. What is a? What plus 0 is 1? A is going to be 1. So that's how they're getting these values. X plus 1 is 2. So 2 plus 1 is 3. 3 plus 1 is 4. So I'm going to graph this. My equation is y equals x plus 1. It starts at 0, 1, 2, 3. Forgot 1, 2, 3, 4. That's what my graph looks like. And I have a multiplicative relationship. What is being multiplied by x? It looks like it's times 2. So this is y equals 2x. With multiplicative relationships, the graph does go through the origin. So we start at 0, 0. All right, multiple representation. So we're going to talk about independent variables. The independent variable is constant, and it is the x value. The dependent variable, it varies, it changes, it depends on the x value, and it is the y value. All right, so my equation is C equals 1050p. So I'm going to give a description for this. So my situation for this example is going to be the price of one pizza is $10.50. What is the total cost, C, of P, the number of pizzas? So I'm trying to figure out how much it costs for a different number of pizzas. So it is a multiplicative relationship. I know it's going to go through 0, 0. All right, so I'm going to make my table. So if I buy 0 pizzas, it's $0. If I buy one pizza, it's $10.50. If I buy two pizzas, it's $21. And if I buy three pizzas, it is $31.50. So my number of pizzas is what's constant when I'm in control of. And my cost depends on how many pizzas I buy. Okay, thank you for watching.